Okay, today we are going to do part of Investigation 3 on quadrilaterals. Part of it we do need to finish in class. So we're going to start out by defining quadrilateral, which is a four-sided polygon, the prefix quad meaning four. We're going to go through the definitions of our basic quadrilaterals, which I believe you already know. A parallelogram has two pair of parallel sides. Now, one little abbreviation you can use parallel lines kind of slanted. So I'm going to be using that instead of writing the word parallel all the time. A trapezoid has one pair of parallel sides. Now, if you have something called an isosceles trapezoid, that's where the two non-parallel sides are equal in length. So where the two non-parallel sides are equal in length. Usually looks kind of like that, where this side equals that side. It's called an isosceles trapezoid. And then you have a trapezium, which is a quadrilateral with no parallel sides. And the last definition for this page is a trapezium. No, it's not. We just did trapezium. It's a kite. And a lot of times you think a kite is a parallelogram, but it's not. It has two pair of adjacent sides of equal length. And you know what a kite looks like. So those two sides are equal, and then those two sides are equal. So that would be your definition of a kite. Okay, and then we go to our specialized parallelograms. We're going to start with a rectangle, which is a parallelogram. Look at the nice little abbreviation there. It's a parallelogram with four right angles. A rhombus has four sides of equal length. Now, it's not necessarily a square, because a square has to have four sides of equal length and four right angles. So this is where we come into, is every square a rhombus? Is every rhombus a square? Is every square a rectangle? Is every rectangle a square? So if we draw a Venn diagram, it might help you. So we're going to put rectangle here. Since a rectangle has to have four right angles, but it does not have to have four equal sides, we can put square right here, which shows that every square is a rectangle, but not every rectangle is a square. Rhombus would come over here. Because every square is a rhombus, but not every rhombus is a square, because not every rhombus has to have four right angles. So you have to try to keep that straight. Sometimes we refer to a rhombus as a square that got tilted over. Okay, one little side note that we just need to go over is the interior angles of a triangle you know that that equals 180 degrees. But what about the interior angles of a quadrilateral? Well, if you think about a square, you know that a square or a rectangle has 4 right angles, so that it's 4 times 90, which equals 360 degrees. So every quadrilateral has 360 degrees, not necessarily 4 right angles. So every quadrilateral's interior angles equals 360 degrees. And that will help you figure out some of the measurements that you need. So we're going to talk about symmetry now. The first type of symmetry we need to talk about is reflective symmetry. And if you have a figure that you can divide in half by a line so that each half is a mirror image of each other, then that figure has reflective symmetry. For instance, in a rectangle, I can draw a line right down the middle, and this side both are identical. They're mirror images of each other, so it has reflective symmetry. On a rectangle, I can also draw a line this way, and the top and the bottom rectangles have reflective symmetry. So there are 2 lines of reflective symmetry in a rectangle. They will be asking you questions on that in your investigation. Rotational symmetry is the second kind of symmetry, and it's talking about rotating an object. And if a figure, as it turns, the original image reappears in less than a full turn, it has rotational symmetry. So think about a square. If you turn a square 90 degrees, it's still going to be a square. If you turn it another 90 degrees, it will still look exactly the same. Another 90 degrees, it will look the same, and another 90 degrees, and it will look the same. So you can turn a square 4 different ways and still have the same image. So it would be rotational symmetry of order 4, because there are 4 different ways it would fit into a puzzle, for instance. Now here's a rectangle. Think about a rectangle. How many orders of rotational symmetry does it have? Well, it has the original one that you start with, which would be a 360 degree turn. But what else could you have on a rectangle? I can take a rectangle and rotate it 90 degrees, but that's not the same position, the original position. But if I rotate it 180 degrees, we have our original image again. So a rectangle has rotational symmetry of order 2. And at what degrees does it have it? It has rotational symmetry at 180 degrees and 360 degrees. If we look at an equilateral triangle, and we want to know if an equilateral triangle has rotational symmetry, think about a clock. If the original point is at 12 o'clock, then we have a point at 4 o'clock and a point at 8 o'clock. If I try to do rotational symmetry on an equilateral triangle, I have rotational symmetry at 4 o'clock, and I have rotational symmetry at 8 o'clock. So yes, a equilateral triangle has rotational symmetry of order 3. And if you have to know what degrees it's at, you take 360 degrees for a circle. Because it has order 3, divided by 3, so it would be at 120 degrees, 240 degrees, and 360 degrees, order 3. So that's rotational symmetry. So if it asks you if a figure has rotational symmetry, You have to tell yes or no, and if your answer is yes, you need to tell at what order number it has rotational symmetry. Okay, so for your assignment today, I would like you to do questions 1 through 14 in the investigation. Tomorrow in class, you need your calculator. So make sure you bring that, otherwise you're going to have a lot of figuring that you're going to have to do on paper. So you're going to do 1 through 14 in the investigation, bring your calculator and those questions to class tomorrow. And anything you might not have understood on this is a lesson that you really should be reading to make sure you understand the symmetry and everything else about quadrilaterals. Thanks.